student, this is the second episode on matter and its surrounding. So till the last one we have completed till diffusion. We have summarized out the portion till diffusion. So before we go to the next part, I would be asking you what is diffusion. Yes, you might be mugging it up. Still, I will be telling you once more the definition for diffusion. It is the movement of the solute from a region of high concentration to a region of low concentration. So, the particles, they are in motion. Whether it is solid, liquid or gases, the particles are in motion. They are not static. Our next part, what we are going to discuss is about the Brownian motion. So what happened, it was Robert Brown who have discovered this motion in the particles. How it is, let us have a glimpse about his experiment. He took a vessel and filled up, half filled with water, and he dusted some pollen grains on the top or the surface of the water, and he covered the mouth with a lid. So the vessel was covered by a lid, and he inspected or introspected inside the material. He saw the molecules, or better I say the pollen grains, moving and up and down throughout the liquid. He observed it. He kept all the doors and windows closed. He kept it on the table, and he came after 10 days, and he watched the material once again from outside, and the glass vessel could give him a clear-cut picture about the molecules, or better I say the pollen grains which was inside the liquid. It was still in motion. It was not at rest. There was no wind, there was no disturbance, but still he saw the molecules are in motion. So when he saw the molecules were in motion, he started thinking about it, that if in liquids they are in motion, it will be also in case of the gases as well as the solid. So student, you please take out your copy and a pen and you jot down what I am saying you now. That is about the Brownian motion. It is a random or zigzag motion. It is random or zigzag motion or movement of particles. Particularly you can write down the bracket microscopic. So it is the zigzag motion or movement of the microscopic particles in a fluid as a result of, yes, as a result of continuous bombardment. What is the spelling of bombardment? B-O-M-B-A-R-D-M-E-N-T. Continuous bombardment of. So it is a bombardment from molecules of the surrounding medium, and this is what we call as the Brownian movement or Brownian motion. For example, dust moves. You know that the dust particles, whenever you close your doors and windows, and if a ray of light is allowed to pass through a small ventilator, you can see that the dust particles start dancing. So the particles are continuously in motion. So dust moves randomly because of the random moving particles of the air which collide with the dust particles. So the air particles and the dust particles, they are continuously colliding with each other, resulting in the motion of the particles. So I gave you 2 points. One was about the pollen grains that you have dusted in water, and the second one is about the dust particles which are continuously in motion. If you ever been in a cinema hall, there you can see the entire room is darkened, and from a very strange point there comes a ray of light. If you see the ray very nicely, you can see the dust particles been dancing, and they are moving up and down. They are continuous. So while you entered the room, it was continuous. While you are leaving the room, the cinema hall, that too, time you can see it is a continuous process. So on the basis of this motion, there are a number of applications that we are coming up these days also. So better you take some examples and suggest. I have given you 2 examples. Now let us see about the characteristics of the states of matter. So how we are classifying solid, liquid, gas, the plasma state and the BEC, that is the Bose-Einstein condensate. There should be some parameters. So with these parameters we can classify as solid, liquids and gases. So what are the parameters? You just write down the parameters for classification of matter. So the parameters are the factors responsible for the classification of matter. Number 1 is based on particle arrangement. How are the particles in solid, liquid, gas and so on, how they are arranged? This is the first point. So based upon particle arrangement. Number 2, based upon the energy of the particles, whether they have a lot of energy or they have less energy. If the energy is more, their motion would be more. If the energy would be less, their movement would be less. As you have seen in solids, they only vibrate. By standing in their mean position, they only vibrate. But in case of the gas, the molecules, they move apart. They move away from their point. They don't have any mean point. This is how it differs from different states of matter. First of all, about the particle arrangement, and number 2, about the kinetic energy present within the particle. And third to go is the distance between the particles. So on the basis of the distance between the particles. This we are going to illustrate very nicely, and I would be asking you to think upon how we are planning for distinguishing the solid, liquids and gases. So I will be showing you a small chart. I will be showing you a small chart where it would be indicating about the solid, liquids and gases. So in this part it will be easy for you to mark up. Why? Because the work would be very simple if you have taken this as a note. So student, let us see here if we can draw up some material between the solid, liquids and gases on the basis of these 3 things. I'll be showing you a bit of it. Please see. So in case of the solid, liquids and gases, so in solid, the constituent particles are very closely packed. In liquids, the constituent particles are less closely packed, while in gas, the constituent particles are far apart from each other. Regarding the point number 2, it is the force of attraction. It is the force of attraction between the particles which is very strong in solids. In liquids, the force of attraction between the particles is less strong, while in gas, the force of attraction between the particle is quite negligible. I will ask you to, if necessary, you can take a screenshot of it saying about the force of attraction between the particles. In solid, they are very strong. They cannot leave. That is the reason why they cannot leave the surface. And the forces of attraction between the particle is less strong than of that solids. While in the gases, the forces of attraction between the particle is quite negligible. So, and that is the reason why they can escape out from the phase, from that part very easily. If we go for the last part, the force of attraction between the particle is very strong. And the next one, we can see The kinetic energy between the particle is more than that in the solid. And in gas, particles have maximum kinetic energy. This is what I want to depict out between the solid, liquid and gases. The picture, here the picture is there, and where it can be shown in solids they are closely packed and the spaces between the solid is very less. In liquids the molecules are quite far apart, there is a good amount of space, and in liquid it is maximum. So student, I have something more to tell you. Students, that we can also have these points together with the solid, liquids and gases, that they have definite shape and volume in solids. In liquids, they do not have definite shape and definite volume. And in gas, neither they have definite shape nor definite volume. In solids, they have high density and cannot be diffused. In liquids, the density is lower than that of the solids and can be diffused. And in gas, density is least and can easily be diffused. And finally to go is about the compressibility. In solid, it is incompressible. And in liquid, it is almost incompressible, but in gas, it is highly compressible. And I have with me some few important questions, and I will ask you to note it and learn it. If you don't know the answer, please ask me. What are the conditions for something to be called as a matter? So what are the things that is necessary to call it as a matter? Why do gases have neither fixed volume nor fixed shape? And how does the smell of the food being cooked in the kitchen reaches us even for a considerable distance? And finally to go is explain why diffusion occurs more quickly in gases than in liquids. So these are the 4 different questions, and I would ask you to write it and show it to me at your convenient time. And there would be some common SI units and things that you have to see. The common units are that degree centigrade, we are not using Fahrenheit. The SI unit is Kelvin, and the relation between the common unit and the SI unit is that 0 degree centigrade is 273 Kelvin. So 0 degree centigrade is 273 Kelvin. So 273 Kelvin is the freezing point. Is it clear, student? So next day we will meet again with the change of state of matter. So our next agenda would be on the state of matter. Till then, have a nice time and goodbye. Thank you.